Hi everyone, how are you today? Welcome back to another video on calculus, and for watching my next videos you can subscribe this YouTube channel. In this video we're gonna find the second derivative of all these functions, so let's start them. The question is find the second derivative of the given function. The first function is fx equals x cubed plus x squared plus x plus 1, and if fx equals y, the derivative of fx with respect to x equals the derivative of y with respect to x, and the second derivative of fx equals the derivative of f prime x with respect to x, and we can write the second derivative of fx in all these forms. Or so in this function, firstly we find the f prime x, or the first derivative of fx. So f prime x equals this function is a polynomial, so the derivative of x cubed is 3x squared plus 2x plus 1, and I used the power rule for solving this derivative. So the second derivative of fx equals the derivative of f prime x, which is 3 times 2x plus 2. So the second derivative of fx equals 6x plus 2. The next function, fx equals x squared times sine x f prime x equals the derivative of the x squared, which is 2x times sine x, plus the derivative of sine x, which is cosine x, times x squared and the second derivative of fx equals the derivative of 2x is 2 times sine x plus the derivative of sine x, which is cosine x times 2x, and for the second expression, the derivative of cosine x is negative sine x times x squared plus the derivative of x squared 2x times cosine x. So the second derivative of fx equals 2 sine x plus 2x cosine x minus x squared sine x plus 2x cosine x. And this 2x cosine x and these 2x cosine x are like terms, and these 2 sine x and negative x squared sine x are also another like term, so you can add them to each other. The second derivative of fx equals 2 minus x squared sine x plus 4x cosine x. The next function is fx equals sine x over x. The first derivative f prime x equals the derivative of sine x cosine x times x minus the derivative of x which is 1 times sine x over x squared. So f prime x equals x cosine x minus sine x over x squared, and the second derivative of fx equals the derivative of x times cosine x minus sine x which is 1 times cosine x plus the derivative of cosine x negative sine x times x minus the derivative of sine x which is cosine x times x squared minus the derivative of x squared which is 2x times x cosine x minus sine x over x squared squared. So the second derivative of fx equals this cosine x goes with this negative cosine x, so the result is negative x cubed sine x minus 2x squared cosine x plus 2x sine x over x to the fourth power. So the second derivative of fx equals 2x minus x cubed sine x minus 2x squared cosine x over x to the fourth power. And the final question, show that for all the integers m is less than or equal to n and m is greater than or equal to 1, the m's derivative of x to the n power equals n factorial over n minus m factorials times x to the n minus m power. And in this question we want to show that the m's derivative of x to the n power equals n factorial n minus m factorial times x to the n minus m power. So for proving this formula, we should know that the m's derivative of x to the n power equals n factorial. So firstly, we suppose that n minus m equals k, so m equals n minus k. So the m's derivative of x to the n power equals, here we substitute n minus k in m, and the result is n times n minus 1 times n minus 2 until n minus k plus 1 times x to the n minus k power. So the m's derivative of x to the n power equals and this equals n times n minus 1 times n minus 2 until n minus k plus 1 times x to the k power. So we know that n times n minus 1 times n minus 2 until n minus k plus 1 equals n factorial over k factorial. So the result is n factorial over k factorial times x to the k power, and here we substitute n minus m in k, so the result is n factorial over n minus m factorial times x to the n minus m power. So we proved this formula successfully. We finished all these problems, and I hope you have enjoyed this video. Don't forget to subscribe us. Thanks for watching. Bye.